Hi. In this video we're going to look at adding and subtracting fractions where the fractions have different denominators and one denominator is not a multiple of the other denominator. So I'll show you an example of what that looks like, but before I do I want to take a step back and do our previous fractions where their denominators are different but one denominator is a multiple of the other denominator. So I've got an example up here where we've got 1/4 plus 1/8. So I'll highlight that in. Now, when we're adding together fractions, as we've covered, we need the same number of parts in each fraction. So when I'm looking down here, we've got 1/4 plus 1/8. We need to change our 4 in our denominator to an 8, right? Because if we convert it to an 8, then we are able to add them together. Now this is easily done in this problem. I can just cut each part into 2. So I'm multiplying my total number of parts by 2. So timesing 2 in the denominator. I'm also multiplying my selected number of parts, those highlighted ones, by 2. Now I'm going to put in brackets what that equals. We've got 2 on 8 plus 1 on 8 equals 3 on 8. And we can easily draw the diagram of that. We've got 1, 2, 3, so we color in 3, and we're done. Now, a key thing that I want to look at here is the total number of parts that we've ended up in. That is a factor, so 8 is a factor. 8 goes into 8 one time. And 4 is a factor. 4 goes into 8 two times. So when we're looking at our total number of parts that we need to add the two fractions together, we need to make sure both the first fraction and the second fraction are both factors of the end result of 8. Now that looks a bit silly for that problem, but it'll hopefully make the next problem a bit easier to understand. So down here we're going to have 1/3 plus 1/4. Now in this example, unlike the previous one, I can't just cut this in half and have the same number of parts in both, right? I can't have 6 parts in here and 4 parts in here. They don't have the same number of parts. So it's not going to work. 4 isn't a multiple of 3, and 3 isn't a multiple of 4. So I can't just simply cut one up into more parts. That's not going to work. So what I'm looking for, just like I did up here, is I'm looking for a number that has 4 as a factor and has 3 as a factor. Just like up here, our 8, this 8, has 8 as a factor and 4 as a factor, which is our first two fractions. So the easiest way to come up with a number that has 3 and 4 as a factor is just to times the two numbers together, right? Because therefore they're both factors. That's the definition of a factor. So if I do 3 times 4 equals 12, and I cut this up into 12 parts, 3 is a factor of 12, 4 is a factor of 12. So then I can cut this up into 12 parts and this up into 12 parts. So I'm going to cut this one into 12s. So we've got 3 there, and then we go 4 this way. Okay, so that's my 12 parts. Now I can easily cut this one in the left up into 12 parts. I just cut each part into 4. And here I can cut each part into 3. Okay, so then we can do our addition really easily. We've got 12 parts here, we've got 12 parts here. You can see this one is 4 on 12. This one is 3 on 12. So if we add them together, we should get 7 on 12. We can color those in. And we get 7 on 12. So what we're looking at numerically is we have 1/3 here. We cut it into 4 parts. So we've got our total number of parts and we've multiplied it by 4. We've got our 1/3 and our selected parts are also multiplied by 4. In the next one, we had 1/4. We multiplied each of the parts by 3, so we have 12 parts in total. And we multiplied our selected parts by 3. Again, we're multiplying, 4 on 4 is equivalent to 1, so I'm not changing the value of 1/3, I'm just converting it to being 12 parts. This then equals 4 on 12 plus 3 on 12, which equals 7 on 12. And we have our final answer. I'll go through one more problem with subtraction. So let's do 1 on 3 minus 1 on 5. So here, if I'm looking for a number that's got 3 and 5 as factors, we just do 3 times 5 equals 15. And I want both denominators to be equal to 15. So I'm going to cut both fractions so there are 15 parts in each fraction. So I'm going to multiply the bottom of this by 5 and the top by 5. Here I'm going to multiply the bottom by 3 and the top by 3. We get 5 on 15 minus 3 on 15, which equals 2 on 15. And I'm done. So what we looked at in this video was adding and subtracting fractions where the denominators are not a multiple of one another. So the strategy was to find a number that had both the denominators as a factor, so 3 and 5, we chose 15. We did that by multiplying the two denominator numbers together. We then convert the denominators so that they're that number, 15, and then we can add them or subtract them together to get our result. I hope you enjoyed the video, and I'll see you for the next one. This video accompanies a worksheet series which aims to develop conceptual understanding around fraction arithmetic. If you'd like to access the worksheets, click on the link in the description.